NASA's Parker Solar Probe has set a new record, flying closer to the Sun than any other spacecraft ever. The 685-kilogram probe skimmed by the Sun, flying just 24 million kilometres above our star's visible surface, just 78 days after its launch. And that's far closer than any other spacecraft has ever gone. The previous record was set by the Helios B probe back in 1976. The Parker Solar Probe's manoeuvre exposed the spacecraft to the intense heat and solar radiation of the complex solar wind environment. The Parker Solar Probe is the culmination of 6 decades of scientific progress. It's allowed scientists to undertake humanity's first ever close visit to our local star, and that's going to have implications not just here on Earth, but for a deeper understanding of the universe as a whole. At its closest approach, known as perihelion, the Parker Solar Probe reached the top speed of more than 343,000 kilometres an hour, in the process setting a new record for spacecraft speed. Along with new records for closest approach to the Sun, the Parker Solar Probe will also break its own speed record as its orbit draws closer and closer to the star, and the spacecraft moves faster and faster at perihelion, with a final close approach of 6.16 million kilometres from the Sun's surface expected in 2024. During its first close encounter, the intense sunlight heated the sun-facing side of the Parker Solar Probe's heat shield, known as the thermal protection system, to about 440 degrees Celsius. If you think that's a bit warm and toasty, temperatures are expected to climb to over 1400 degrees Celsius as the spacecraft makes closer and closer approaches to the Sun. But all the while, the spacecraft's instruments and systems will be protected by the heat shield, which amazingly should keep them below 30 degrees Celsius. The Parker Solar Probe was launched aboard a Delta IV Heavy rocket from Space Launch Complex 37 at the Cape Canaveral Air Force Station in Florida on August 12, 2018. All in all, the spacecraft will use 7 gravity assists around Venus to incrementally shrink its elliptical orbit around the Sun during its 7-year mission. The Parker Solar Probe's the first spacecraft to fly into the lower solar corona. The mission's designed to trace the flow of energy that heats the corona and accelerates the solar wind. The Sun's visible surface, the photosphere, has a temperature of around 6,000 degrees Celsius. Relatively cool compared to the many millions of degrees at the Sun's core. And that's because normally things get cooler the further away you are from the heat source. And that's where a big problem arises, which the Parker Solar Probe will hope to answer. You see, the Sun's outer atmosphere, the corona, has temperatures of more than 1 million degrees. So instead of getting cooler the further away you are from the Sun's heat source, things are getting hotter, and scientists want to understand why. We think the reason for this is a process called magnetic reconnection, a sudden release of energy caused by magnetic field lines connecting. Astronomers also want to study the structure and dynamics of the magnetic fields at the source of the solar wind. And they want to determine what mechanisms accelerate and transport energetic particles away from the Sun. To do this, the spacecraft is equipped with 5 primary science instrument packages. There's an electromagnetic fields investigation to make direct measurements of the electric and magnetic fields, radio waves, Poynting flux, absolute plasma density, and electron temperature. There's an integrated science investigation to measure energetic electrons, protons, and heavy ions. There's a wide-field imager comprising optical telescopes to get images of the corona and inner heliosphere. A solar wind electrons, alphas, and protons instrument will count electrons, protons, and helium ions and measure their properties, such as velocity, density, and temperature. Finally, there's the heliospheric origins with Solar Probe Plus study, a theory and modelling investigation to maximise the scientific return from the mission. To find out more, Andrew Dunkley is speaking with astronomer Dr. Fred Watson.
Now, Fred, we head towards the Sun, the Parker Solar Probe. Well, it's now approaching its destination. That's the fast part of the project, literally fast. We'll talk about that too. But now it's got years and years of work to do.
Indeed, that's right. So its destination is a series of orbits that will take it ever closer to our parent star, to the Sun. The Parker Solar Probe is designed to answer some of the really deep questions about the way that the Sun works. I might list them in a minute. But the bottom line in terms of the news at the moment is that after a successful launch on the 12th of August, not that long ago, it has now actually broken a record because it has become the closest human-made object to the sun, and it'll continue breaking that record throughout its mission, which goes for almost 7 years. So at the moment, it's within 40 million kilometres of the sun. Remember, that compares with the 150 million kilometres that we are away from the sun here on Earth.